Today we are going to be talking about aldehydes. What is an aldehyde? What are its functions, UPAC rules for aldehydes, and how do we name them? And I hope you enjoy the presentation and learn from this.
Aldehydes are any class of organic compounds in which a carbon atom shares a double bond with an oxygen atom, and a single bond with a hydrogen atom, and a single bond with another atom or group of atoms. The double bond between carbon and oxygen is a characteristic of aldehydes and is known as the carbonyl group. Many aldehydes have pleasant odors, and in principle they are derived from alcohols. Aldehydes are also useful as solvents and perfume ingredients as
There is only one structural difference between a hydrocarbon and an aldehyde, and it is the presence in the letter of the carbonyl group. This group is responsible for the differences in chemical and physical properties. These differences arise because the carbonyl group is inherently polar. This means that the electrons that make up the carbon-oxygen double bond are drawn closer to the oxygen than the carbon, and this gives the oxygen a partial negative charge and the carbon a partial positive charge.
Okay, I'm going to talk about the applications and functions of aldehydes. Aldehyde is found in a gaseous form. However, with 30% water forms formalin. Formalin helps in preservation of biological specimens. The third reaction is with formaldehydes and phenol. It creates a reaction called bakelite. It is found in plastics, coats, and adhesives. It is used as germicides, insecticides, and fungicides, but it is also used to test drugs and photographies. But one of its main uses is for the creation of cosmetics, perfume, and hair dyes.
I'm going to talk about the UPAC rule for the aldehydes. First of all, some of the common names for aldehydes do not strictly follow official guidelines, such the ones are recommended by the UPAC, but the rules are very important. Here we're going to prescribe the nomenclature aldehydes by using the UPAC rules. First, we have the acylic aliphatic aldehydes, that these ones are named as the derivatives of the longest carbon chains that the aldehydes contain. For these ones, forming the name, we're going to change the suffix E of the parent alkane to the suffix Al. So an example will be ACHO, that this one is named as derivative of methane. So by forming the name, it will be methanol. Another example is CH3, CH2, CH2, CHO. The difference is a derivative of butane. For this, the name of this one will be butanol. There are other cases such as CHO that this group is attached by ring. The suffix that we will be using for this one is carbaldehyde. One example is C6H11CHO. So by naming this one, will be named as cyclohexane carbaldehyde. For carboxyl acid, we'll use the prefix oxo, which indicates which carbon atom is part of the aldehyde group. For example, CHO, CH2, COOH, this one will be named as trioxopropanoic. If we replace the aldehyde group for the carboxyl acid, we'll be using the suffixes IC acid or OIC acid.
Before naming aldehydes, we need to know some history and some rules behind. First of all, the UPAC system of nomenclature assigns a characteristic suffix to aldehydes. This suffix is al. Number 2, an aldehyde carbonyl group must always lie at the end of the carbon chain, and it is always given the number 1 location position in numbering, and is not necessary to include it in the name. Aldehydes obtain their names from their parent alkene chains, and the E at the end is removed from an al. That al is the suffix assigned by the UPAC system of nomenclature. Another thing we must know is that most common names of aldehydes start with the parent alkene chain name, and then you add the suffix aldehyde. Another important thing about naming aldehydes is that when we are naming unsaturated aldehydes, we must give priority to the carbonyl group over the double bond when we are deciding which end of the carbon chain begin numbering. As I said before, a carbonyl group must always be given the position number 1 in numbering. Therefore, counting starts at this carbon. Let's take a look at our first example. Now, the first thing we need to do is identify whether this is an aldehyde or not. It is very simple. We have our proof right here. An aldehyde has a double bonded oxygen attached to the carbon and a hydrogen attached to the carbon. A difference between an aldehyde and a ketone is that a ketone does not have a hydrogen attached to the carbon. So now, knowing that this is an aldehyde, let's get started. The next thing we are going to do is number our locations. As the rules say, our carbonyl group is located at last, so following the rules, we need to start numbering our carbonyl group since the first location. So this is number 1, position number 2, position number 3, and position number 4. Now that we have our positions numbered, we are going to find our longest chain. This is our longest chain, and we are going to start counting from our aldehyde carbonyl group. So we have a 1, 2, 3, and 4, a 4-long chain. So what is its name? It is called a butane, but remember that the rules say that we need to drop out the E and replace it with an Al. So it's going to be a butane. Now, let's find if we have something else. As you can see, we have a methyl here. So now that we have our longest chain, we have our methyl group, we can name our aldehyde. This is called a 3-methyl-butane. You may ask, why didn't I add this number? Well, as I explained before, our carbonyl group is going to be located in position 1, and it is not necessary to include it in our name. Now, let's do another example, but instead of using compact structure, using skeletal structure. Now, we are going to identify whether this is an aldehyde or not. We know that if we have a double bonded oxygen attached to the carbon and a hydrogen attached to the carbon, this is an aldehyde. So now we can start counting. Remember that the rule says that we have to give the aldehyde the number 1 position in numbering. So we are going to start counting from here. This is going to be position number 1, position number 2, position number 3, position number 4, and position number 5. After numbering our locations, we are going to find the longest chain. Start counting from the aldehyde carbonyl group. So 1, 2, 3, 4, and 5. This is our longest chain. What is its name? This is called pentane. But we have to recall that the rule says that we need to drop the E and replace it with an Al. This is the suffix for aldehyde. Now, let's look if we have any other group. In here, we have a methyl group. So this is a methyl group located in carbon number 4. So now we have the name of the longest chain and any other group in the aldehyde. So now we can start naming our aldehyde. It is going to be called a 4-methyl pentanol. Why? Okay, we have our methyl group in carbon number 4. That's why this is the number of location. So the name of this aldehyde is 4-methyl pentanol.